Hello, good morning or good afternoon, and welcome to Production Pulse. I am Robert Schoenberger, Editor-in-Chief of IndustryWeek, and this is our bi-weekly show where we discuss manufacturing topics with newsmakers in the field. I have two guests today. I have Jonah Meyerberg, who is the Chief Technology Officer at Desktop Metal, and Dennis Mecca, who is our technology editor here at IndustryWeek, and we're going to be talking about additive manufacturing in advance of the Rapid show, which is next week in Chicago. It's always an interesting topic to see what's going on in additive, and Jonah's here just to talk a little bit about what's exciting and new in that space. So welcome, Jonah.
Thanks, Robert. Great to be here. Great to be talking to you guys.
Thank you. And I'll just kick it over to Dennis. Dennis, you had a couple questions for Jonah about what you're seeing in additive these days, so let's just go right to it.
I was wondering how familiar manufacturers are generally with additive nowadays. Is it just another tool in the toolbox, or is there still any hint of the exotic anymore? Does that make sense?
It does. It does. And, it certainly continues to be a small space in the area of manufacturing in general. And hey, the additive community is really tight and small, and we think that additive rules the world. But as you get out there into traditional manufacturing, you realize how huge the opportunity it is to bring additive into areas of manufacturing that just haven't used it before. So it is another tool. It's being taught by universities as another tool, finally, which is a great thing. Because when I went through university at Lehigh University and Johns Hopkins, we didn't have courses in additive manufacturing, right? We had courses in manufacturing that covered casting and stamping and machining. But now those same courses include additive, which is the first step, is you've got these students, these engineers of the next generation that were all born with iPhones in their hands and have immediate need for satisfaction. They are the ones demanding additive to be used in not just development, but in mass production. So these tools are coming into every industry. They're new to industries, but they're becoming a lot more common.
How often do you find that these students or these engineers kind of are additive enthusiasts as well? They have machines at home. They're just printing household objects. How often does that happen? I was curious.
Yeah, I mean, almost 100% of the time. I mean, you talk to engineers nowadays, and everyone has a polymer 3D printer at home. We hope one day everyone has a metal 3D printer at home, but at least you've got one in the classroom nowadays 100% of the time, and even in high schools. At maker labs are extremely common, universities and high schools. And so I think that it's not just it's not the same as kind of when we were younger, where you didn't really have that hands-on access to the machines. You kind of had to send your CAD file over the wall, and then you'd receive a part back. These engineers nowadays are used to running their own machines.
How long do you think we'll be able to walk into a Best Buy and just buy one off the shelf?
Right.
It's good to go. It doesn't have to be modified. Just it's like a refrigerator or a stove. Just put it in your living room. How long do you think? How far away from that?
No, it's happening now. You can go to Home Depot, and Home Depot sells 3D printers. We're talking about small polymer 3D printers, right? You can order them anywhere, but and even Home Depot and Lowe's had programs in which you could send CAD models to the big boxes, and they would print, custom hardware. Now, those never took off or haven't taken off yet in the way that they would like to. But you've got companies like Stanley Black & Decker and Milwaukee Tools who are looking at how do they enable their partners like Home Depot and like Lowe's to do that type of work. And so that's absolutely coming soon. But yeah, you can walk in and buy a 3D printer right now.
Earlier this week, I was talking to the head of a makerspace at Case Western Reserve University here in Cleveland, and she was telling me that at this point, it's no longer just the engineering students coming in. That was the traditional experience. It was the engineering students coming in trying to do one part. She's seeing students from the Cleveland Institute of Art coming in and wanting to work on a project, or music students who just had an idea for maybe doing some different kind of stand. That it's really getting democratized across the entire student body, not just for those really technically minded students these days, which should be really interesting to see how that affects you guys in a few years when it comes to who's willing to use the technology.
Absolutely, absolutely. So I think that universities may have been kind of the first model for that. I've visited the maker spaces at Lehigh University, and at Johns Hopkins University. There's a maker space called Fast Forward U. These are areas where any student within the university can mail off an STL file or send off an FTL file to a central server and have it produced. Now that's useful in almost every class that you take these days, is to have that ability to create a CAD file or even just download a CAD file, send it off, like to a printer that would be in your dorm room or your dorm or your office space, and have it just printed. Now, of course, these spaces encourage the students to come in and learn how to use the printers as well. But that is becoming extremely common, and it's not just in universities now. It's almost like you can have a service provider in a city or in a town, like a library, where you in your neighborhood can send it off to be printed. In fact, there's the state of Michigan has worked with a World Economic Forum to gain funding for what they're calling these maker networks, in which these different small businesses throughout the state of Michigan can apply for funding and get a free 3D printer. And that free 3D printer, the only thing that comes with it is that it needs to be networked with the greater state. And if there's a pandemic, or if there's a need for 3D printed parts, the alarm can go off, and all of a sudden you've got hundreds of 3D printers at your fingertips, to go make whatever you need to make.
That's cool.
Yeah, one of the things I saw recently, there was a great video of a Chat GPT integration into Autodesk, where the person was kind of speaking out loud, giving the verbal commands to the computer, which was then kind of using the AI to translate that into specifications. And I looked at that and I was thinking, metal 3D printing, how far are we away from that Star Trek replicator when we can just say, computer, make this, and here are the general dimensions I need. Is that a realistic idea? Is that something we could imagine in a few years, or that's still a little too sci-fi?
No, not at all. We're seeing that happen right now. I'm really excited about all these different software tools that are being developed and around this ecosystem of 3D printing, and we're already seeing AI play a huge role in that. You mentioned in AutoCAD, but the kind of the text and voice to CAD that's being demonstrated right now is just mind blowing. It's amazing. It's where you can teach an AI to take a 2D image and turn it into a 3D image. That's pretty straightforward. But now you can teach an AI to build the CAD model based upon the software that you're building it in. Like, grab a sketch, make a circle, extrude it, and it can be smart enough to understand what cylinders mean, what parts mean, and design that part for you. So AI is getting deep into the CAD world. We've already seen it in generative design, right? Generative design, you give it some constraints. You don't tell it anything about the geometry. You just push and pull on some end effectors, and then it builds the geometry in between, and it does it more efficiently and effectively than an engineer can do. So we've seen that. In fact, Desktop Metal's Live Sinter does the same thing on multi-physics modeling of the way that parts the geometry changes and the stresses that happen in the parts as they're being built through additive manufacturing. That all becomes predictable. And the reason why AI is so important is because the geometry is never the same. The geometry always changes. You need an intelligence that can look at any geometry and understand exactly how gravity pulls on it, and how friction pulls on it, and how it's going to move and shrink and consolidate as it goes through the printing process. So this type of AI in designing for the additive manufacturing process, I think we're going to see more of that come out. Like, showing a part to an AI and having it select the technology that would be preferred for manufacturing it, whether it be whether it be AM or another traditional manufacturing process. And then if it is AM, right, the AI can go through the entire build prep routine, building supports and determining the best orientation for printing, and then then instancing it as many times as you need within the bed in the most effective way. There's so many advantages within AI. Within additive manufacturing, there's so many advantages to design that we're just not tapping into because they're hard. taking existing assemblies and consolidating them from 100 parts down into one part. That takes an engineering. It takes a lot of engineering hours to do, and you can plug that into an AI and get the result a lot faster. So I'm really looking forward to seeing more and more AI software built into additive.
That's great. Dennis, I think you had a couple more questions.
So not every manufacturer is using additive right now. It is a tool in the toolbox. They may not need it immediately. But when a manufacturer is bringing in new engineers, how important is it to have at least one person in the shop who's either familiar with it or experienced with it or just enthusiastic about it? How important is it to have that one guy in the shop who can get you on board when it comes time?
I think it's extremely important, not just that one guy. You got to think of additive as not just kind of a nice thing to have or another tool in the box, but it's a mentality, it's a way of thinking. So just like let's say you've got a machine shop. How many guys in a machine shop know even just a little bit about the way machining works? I mean, basically every guy in that shop understands what they're doing. And so you introduce additive into a shop, everybody in that company needs to understand at least a little bit on what it means to design for additive and then to go through the production process, what it takes to get you to where you need to get to, and then what type of post-processing is going to be necessary after the fact. Once you do that, then you start to really, really move like a well-oiled machine.
Oh, that's great. It's the growth over the past few years. I mean, this has been a field. I think I first saw my first 3D printer, my first metal 3D printer, almost 20 years ago in southern Mississippi. But that was a sinter machine that you had the wax, you melt the wax out and then use the capillary action to pull the copper back in. Still very much a prototyping technology, not a production technology 20 years ago, but it's changed so much since then. With the Rapid show coming up next week, what's exciting to you? What are you seeing on the horizon in the technology that has you excited these days?
Oh my God, I'm so excited for Rapid next week and all of the new entrants and the new technologies that we're going to see. I mean, Rapid is the one of the biggest shows in the world, right? It's the biggest 3D printing show in the US. And so there's always going to be something special. But what we are expecting and what we are seeing there's a whole nother group of entrants into the binder jetting space, which is extremely encouraging for the industry in general, because binder jetting is the answer to bringing additive manufacturing into mass production. It's the fastest, lowest cost, most effective and efficient way of producing metal parts. So with new binder jetting entrants, we're seeing new momentum. We're seeing more confidence building through the customers. So that's super exciting. We're also seeing bigger, faster, and more powerful DLP printers for polymers coming into the space, and with the technology flipping on its head. So doing a top-down type of DLP print instead of a bottom-up. And what that allows you to do is produce bigger, heavier parts through the DLP process, which is much faster, higher resolution, and much more powerful than a laser-based SLA. So these new DLP top-down printers are allowing for new materials to come into the space, tougher rubbers, elastomers that are going to change the game, chemical-resistant materials, high-temperature materials, and even foams. And the foams are really exciting because there's nothing like them out in the space. Foam polymers have been mimicked for a decade. You can imagine printing lattice structures that are supposed to be soft and act like a foam and cushion your feet if it's in a sole or in your helmet. But they're not foams. They're solid rubbers. They act differently. They absorb energy differently. But real foams that have closed cells, that have predictable geometry and are able to be rapidly prototyped, change the game in that space. And so we're really excited for that and to see what types of new applications come out of that. And the new types of geometries that are capable for in that space. We also, past Rapid, we're really excited about a show called GIFA, which happens every 4 years, and it's a casting expo in Germany, and digital casting, so 3D printed castings is a very mature space. It's sand printing, and it's a very mature space that we see where our customers have fleets of these sand printers, and we think that is going to happen in metal printing and polymer printing as well. We have over 300 customers right now with full fleets of printers. That's 3 or more machines, and some of them with over a dozen machines, called super fleets. So we think that the space in polymer printing and metal printing is going to follow that space in the sand printing. So that's really exciting.
Right, I mean, Desktop L, you bought X1, what is it, about a year and a half ago, 2 years ago now, which was very much in that sand casting space. So it's part of your lineup, and it's a fascinating part too.
It is. It's another way to produce metal parts.
Great. Dennis, you have any last questions for Jonah while we still have him on the line here?
Yeah, whenever I talk to people about predictions, a lot of it has to do with getting closer to mass production. We just talked about there are different additive techniques, different materials. Is there a single logjam? Is there a single advance that really needs to happen before you see additive adopted widely for mass production? Is there something that the community really is still working on? Does that make sense? Is that a fair question?
Yeah, no, it's a great question. It's a great question because what we're seeing are a number of different technologies right now being applied to mass production. And what's going to bubble out of this, what this will reduce to, is a few that can be applied in different areas. And certainly we're seeing sand casting, so digital casting, sand printing is being applied to mass production now globally. So that is one mature market. And that's one way of making steel, aluminum, copper, brass components. You have a lot of opportunity there, but you're also printing the negative and casting the positive. That, as we go into direct metal printing, the longest running technology, I should say, the most the direct metal printing technology has been around the longest, over 20 years. As you were saying, Robert, laser-based printing has been evolved for the aerospace market over the last 20 years, and it is getting to the kind of this point of steady growth, kind of diminishing returns and acceleration. It's focused on expensive components, not high volume components, and we need to change that. We need to go into the space of what you're describing, which is high volume production, automotive production, industrial production, consumer electronics production. We want to be making millions and tens of millions and hundreds of millions of parts, and to do that, we need to change the entire picture. Lasers are just not going to scale that way. The only way to do that is with high-speed printing, digital presses, the way that 2D printing has scaled from a printing press to a digital printing line. And that's happening right now with binder jetting. Binder jetting is scalable. Now, is everything perfect in binder jetting? There's absolutely improvements that we can make. Is there one that we can point to? There's probably a couple areas that we're focused on, making the parts stronger and more robust for automation. And I think as we push in that direction, you're going to see the adoption just exponentially grow.
Well, Jonah, thank you so much for your time today, and Dennis, thank you. I appreciate it. It's always fascinating to hear from the experts on these growing fields. And thank you to everyone who's listening out there. Again, this is Robert Schoenberger with IndustryWeek, and join us in 2 weeks for our next Production Pulse. Have a great afternoon.
Bye, everybody.
Thanks.